So let's talk about heat and heat transfer. It's one of the foremost concepts in HVAC because everything HVAC has to do with the transfer of heat, taking heat from a place we don't want it and moving it to a place that does not matter. So how does heat move? There's three types of heat transfer that you should be aware of in HVAC. One is conduction, two is convection, and third is radiation. So this is how heat moves around. Heat transfers. Heat is always going to move towards cold. It always wants to move to a cooler place. Living in Phoenix, you already understand the desire to get away from heat and to hide from heat. Even heat doesn't want to be around heat, and so it's always looking for a cooler place to be. What I mean by heat transfer is how heat moves from one place to another. So we have conduction. Conduction means that the heat will always travel through a substance via energy transfer through molecules. So what that means is if I have a piece of copper tubing and I'm heating one end of it, the heat will travel through that and eventually burn my hand. That is conduction. Heat traveling through a substance. Convection is heat traveling through air or water, basically. It's traveling through a fluid. And air is a fluid, believe it or not. So, convection is heat traveling through air. And if you picture a gas furnace that has a heating element in it that is being heated by gas, and there's a blower pushing air across that heat exchanger, and hot air comes out the other side. Heat is traveling from that heat exchanger through the air out into the house. So heat is being transferred through a fluid. That is convection. Radiation is the sun, or a heating element in a heater that you've probably seen. With radiation, the heat travels from the sun 93 million miles or whatever to the earth. As it's traveling, it doesn't heat up the space around it. It just travels. Most likely in a wave. I don't know. I'm not a scientist. But it travels, it radiates, and it doesn't heat anything until it comes into contact with the surface. When it comes into contact with the surface, it heats that surface. But the whole travel, it doesn't heat space, it heats the first thing it runs into. So that is radiation in a super non-scientific terminology. Another way to observe conduction of heat is to think about heat moving from your body to another substance. So this is my metal ice bucket in my freezer, and this is ice cream. This is meat. Meat. If I take one hand and put it on the meat, pause, and the other hand and put it on the ice bucket feels way colder. This is the same temperature as this, but this metal conducts heat away from my hand at a much higher rate. It's a better conductor of heat, so it feels colder. If you're outside on a cold winter night and you touch a fence post and you touch the fender of your car, the fender of the car feels colder. The metal feels colder because it has the ability to conduct heat away from your hand at a higher rate than the wooden fence post. So you can touch two things that are the same temperature, but the rate at which they conduct heat away from your body is going to change how they feel. Because what you're really feeling is heat leaving your body. Another thing to look at conduction is the pan on the stove. Now this can be looked at a couple of different ways because really that heating element in a way is radiating heat. So we have kind of an example of radiation and conduction. It's radiating heat to the first surface it runs into, which is the glass top, which is then transferring the heat into the water, into the pan, and then into the water. So this is a form of conduction. I would say conduction via radiation. What's the best example of radiation? Ta-da! Where is it? Ah, it's right there. The sun. The sun radiates heat all the way through space, 93 million miles, and it doesn't change the temperature of space. So radiation travels, and the first solid substance it comes into contact with gets hot. It radiates. It just travels. It doesn't heat the area around it. It just travels until it hits an object and it heats that object. That's radiation. And that's why that heating element can be considered radiation until it hits that glass, and then it becomes conduction. Here's another example of radiation heat. The toaster. See? The heating elements inside there heat up and they radiate heat. When the bread's in there, it hits the bread. That's the first solid surface it heats, and it toasts it. That's another example of radiation heat. So we have conduction and we have radiation. What's left? Convection. Now we're in the garage. An example of convection is a heat gun. Convection is the transfer of heat through a fluid, like air is a fluid, or water. So, the transfer of heat through water, convection. The transfer of heat through air, is convection. This is heating up, and it is moving air across it, heating the air, and the air is moving the heat. Ma. Convection. Now, all that being said, is convection, conduction, and radiation terms that you are going to deal with consistently every day in the refrigeration field? Probably not, but they are important concepts to understand. It's very important to understand how heat gets from one place to another, because that's what we're dealing with in refrigeration. The transfer of heat from a place to a place. What's important to keep in mind is heat transfers to refrigerant or to water, and it transfers from refrigerant or from water. Heat transfers in, heat transfers out. It transfers into a vehicle, it is moved to a place that does not matter, and it is rejected to a substance or a fluid that does not matter. In residential, mostly it's going to be air. You're going to be dealing with air transfer. It's going to pick up the heat from the air inside the structure. Same with the refrigerator. It's going to pick up the heat from the air passing across that coil, and it's going to transfer that heat into the refrigerant. The refrigerant is the vehicle for the heat. It's going to move that heat to a place that does not matter. The outdoor air moves in through the coil and takes that heat from the refrigerant and rejects it to the ether outside. So we're taking the heat from inside, moving it outside, using the refrigerant as a vehicle. So the big thing to understand is that all this stuff we're learning, all this equipment, all these big fancy words and confusing concepts are all based around one thing: moving heat. Heat transfer. Taking heat from one place and moving it to another place. That's what it's all for. All this stuff. So hopefully this helps. This is the first concept, heat transfer. We take heat from a place and move it to a place. That's what all of it is about.